we're going to be covering our heads, right? Or your heads, your head assembly, your head one, head two. You'll hear it called all different things, right? My goal in this is just to give you a good familiarization. Okay, so anywhere you go to work, you're going to probably run into drawings, fabrication drawings, prints, all not being the same. Although there is an industry standard, everybody always has their company standard. So my goal here is just to give you a good generalization of what these parts are, what they're commonly called, and best practices of how they're put together. So when we're talking about our heads, we're talking about these end caps that are on each side of these pressure vessels, right here and right here. Those are your heads, 2-to-1 elliptical heads for this job, and we'll go over the specs on them here in a minute. But I just want to go over what they are, where they're placed, and how they're called out. So if you look right here, you'll see number 2. This is number 2, and then if you go to the far side, this is number 1. So those are your references in your bump. So if you go up here to 1 and 2, you see head number 1, head number 2. So the reason why it's labeled that way is because these heads have their own separate drawings. So if you scroll down, you'll see these. So even though there is nothing that needs to be done to this head one, I still include it on the drawing. That way, whenever the production team goes and orders these heads for this job, they have all the information that they need, and not to include headman thicknesses. So if this is an ASME code vessel, that's very important. Your headman thicknesses. If it doesn't meet that thickness requirement, then it can't be used on this job. So even though this head is a 1.75, which is 1.75 inches thick, there are minimum thicknesses. And when we're talking about minimum thicknesses, we're talking about where this head starts to thin whenever they form it. So what I mean by that is this head essentially it starts out as a flat piece of plate. So let's think of this as a flat piece of plate, right? So what they do is they do a bump and spin method. They basically apply pressure right here, and they spin it around, and they press on it to form this head curvature. So when they do that, it causes thinning. So your thinning is going to be right here. That's where your thinnest parts are going to be, right there. Sometimes you'll see even there's a little spin hole that'll be created depending on how much pressure it is whenever it's being manufactured. But I don't know a whole lot about that. I just kind of know generalities because I just wanted to know how they manufacture these things. So anyway, it's a bump and spin method, I think is what they call it. So anyway, headman thicknesses. So that's what they mean by headman thicknesses. So even though this piece of plate was started out as 1.75 inches, once you start spinning it and forming it, you'll have some thinner spots, typically right here on those knuckles, and that's what this is referring to. Those parts, or those areas, really any area, but you're going to find the most affected area is going to be right here and right here, that they can't be less than 1.65, which is 1.5 inches thin, or else we can't use this head on this particular job because it won't pass the calculations. So anyway, that gives you a little bit of understanding on headman thicknesses and what I mean by that. Now we'll go to, and that's really why I like to include it on its own page, because believe it or not, sometimes you'll have two different size head thicknesses on each side of the pressure vessel. You commonly see that in fire tubes whenever it comes to heater treaters. But it's best to use the same head thicknesses on both sides. But sometimes you'll see different head thicknesses on different sides of the vessel, just depending on the job. But anyway, we'll go up to head number 2. So head number 2 is right here on the far side, and we'll go over that. And again, the reason why it's laid out this way is because whenever it gets to production, whenever they actually go in and start producing this pressure vessel, this job and the company that's doing this has their own fabrication setup, where there's basically a guy that's going to be out there building this head while other guys are working on the shell assembly and other guys are working on the saddle. That way they kind of spread the workload. and to get it done on time. So we build them this way. That way they have their own separate print that they can look at, and they can reference without having to flip through too much, finding what they need to build this head assembly. So anyway, looking at this head assembly, we got a couple different parts. We have 1, 2, 3, and 4. So we have the head right there, which is just referencing your head we just talked about, and it gives you a description: 48 OD outside diameter, 40 inches outside diameter. The thickness of this head is 1 3/4 nominal, 2-to-1 elliptical head, and this is your grade 516-70 normalized. Okay, so that gives you your grade. And then I was looking at something real fast. Where am I? Okay, so we'll go to the next one, which is number 2 right there. Number 2 is referencing this nozzle connection, which is your raised face long weld neck, 8-inch, 600-pound. The bore size inch and 0.375, inch and 3/8. So again, it gives you your grade over here, and this is your nozzle detail. So your nozzle is going on the end. Let's go over some dimensions on it. So your dimensions are 22 inches from the bevel to the outside of the face of flange. It's important to give them that dimension, and it's important to give it to them that way. Sometimes I've seen it, and I don't think it's correct. Somebody may not agree with me, but I'm sorry, I don't think this is correct. So some people will give them dimensions from this curvature of this head. So you can't do that. And the reason why you can't do that is because although there's a method that they use to build these heads, they never come out the same. The head curvature is always going to be a little different, which is going to throw off your measurement. So if you ever see a head curvature dimension, either from the high side or the low side, and there's a dimension here, 8 inches or 10 inches, whatever the case may be, I don't think that's a good way to do it, because if you can build 7 of these, line them up, and if you're doing that kind of dimensioning off of the head, you're probably going to be coming off. It's not going to be correct. So the best thing to combat that is to give you a dimension from the beveled edge, from the factory beveled edge to the face of flange. And that's the way I've always seen it done, and that's the way I see it, that it'll always work better. So it's something that I think it's important, and it's important to understand, especially as a fabricator. If you don't see a dimension like that whenever you're pulling for a head or a good reference point, then you might want to go back and question that, because you might come up off, and then they'll try to blame you. But anyway, that's your overall dimension from bevel edge to face of flange. And then right here is your offset dimension. Right here is your center line. This is the center line of your vessel, of your head, and we're offsetting it up 12 inches, and that's the center of your nozzle. So, and it's labeled N1. N1 is your inlet. So if we go back up here, we'll see an N1 identifier right there, and we'll go to our nozzle reference schedule, and it'll let us know what it is. N1, 8-inch, 600 raised face weld neck, long weld neck, inlet, and it gives us the bottom reference to where to find it. So those are important to be in the right place, because that way you can go and find information you need on it. So next is number 3. Number 3 will be a part of your inlet diverter. It's a 1/2-inch piece of plate cut from 96 by 240 inch piece of plate. It's an inlet diverter, and it's a SA 36 grade. So this is what we're talking about right here, your inlet diverter. It's a 1/2-inch piece of plate. It's always good to be thick on your inlets, because that's what's taking the initial impact of the emulsion coming in to help separate these your emulsion. So right here just gives you your dimensions of it. That way, if you needed to, you can lay this out and cut it out by hand, or if it's going on the burn table, plasma table, they can verify these dimensions before cutting it out a 1/2-inch plate, and possibly not cutting it correctly. So it's just a good reference. That way they have it so they can see it. And again, it's got a call out bubble, inlet diverter plate, overall dimensions, center line, It just gives you as much information as possible. That way, it's very easy to see, and there's no doubt in your mind of what it needs to be. Again, and then the other part of this inlet diverter will be number 4, and that is just 10-inch pipe, right? So basically, it's a piece of 10-inch pipe. This is the side view. This is the right elevation view, and we're cutting it right here, right there, and right there, and that way we can weld it on there. Again, gives you dimensions and overall dimensions of it, and it gives you the call out number 4 right here, and number 4 will tell you what kind of pipe it is. 10-inch outside diameter. It's a half-inch wall, schedule extra heavy, seamless pipe, again 12 inches, and then your material grade. So that's your inlet diverter assembly. It welds. You have the detail right here. I'll give you a typical detail of your weld symbol. I think we went over once the weld symbols are ready, and that'll let you know what type of weld procedure to do on that, and that way you can get that welded on there just fine, the way it's called out to be. So, and there's your inlet diverter in isometric view. That way you can kind of understand what it looks like. So again, emulsion comes in, splashes, and begins separation of your oil and your water. Okay, so I think that's pretty much it. Other than nozzle detail, I didn't go over that real too much. But again, you see this dimension right here. That's not a good dimension to have. If you give them that dimension and you give them this right here, they're gonna come back and ask you, hey, which one is it? Because those two, I promise you, those two dimensions aren't gonna match up. More often than not, they don't. So that we should just get rid of completely and not have it on there. Inside projection. So this is very important, and you'll see that either on your calculations or your engineer will give it to you, depending on if it's ASME code or non-code. And that's called out on your code calculations. That way you don't even have to think about it. You got to always make sure, this is letting you know that you have to make sure that from this point to the end of that piece of pipe, it needs to be at least 1 inch minimum. It can be more than 1 inch. It cannot be less than 1 inch, or else this will not pass inspection, and we'll have to end up reworking this head because it didn't work. It doesn't meet specifications. So very important to know, very, very important to understand, and it's very important to follow. So anyway, after that, I'm gonna look at this weld symbol right here. So this weld symbol is telling you that you got a bevel on your head, and you got a half-inch fillet weld inside and half-inch fillet weld outside. So bottom side is arrow side is always the bottom. So basically, where this arrow is pointing to, that's your half-inch. That's going to be your half-inch. So bottom is always arrow side. So arrow side is going to tell you, hey, you need a half-inch fillet weld on that side, and you got a bevel, and you also need a half-inch fillet weld on the inside. And this little circle right here represents that you're going to be welding all the way around this piece of pipe. So think of this as think of this nozzle as a I'm gonna try to draw this out for you, that way you can kind of understand it a little bit better. But think of this bevel, this head having a bevel on it, right? So it's beveled out right there and right there, okay? And that's to help get better penetration. And that's what that bevel right there represents. It's a beveled V groove. That way you can get a good weld in there. And then we're looking at this half-inch, and that's telling you that we have to throw a half-inch piece or a half-inch size weld on this side. So that needs to be half-inch, right? For that one and this one, half-inch. And then we also need another half-inch weld, but this is going to be on the inside. So welding right here and right here, same half-inch on both sides. Well, all the way around, basically. So this is a section view. So basically what we're looking at is, if we were to slice this thing in half, this whole vessel or this whole head assembly in half right here, this is what we're looking at, is this side view. See, it's a section view. And then we kind of just put it into a little detail view, that way you can see it. So basically it's just sliced in half for better clarity. But anyway, I think that's about everything on heads. Uh, General stuff. Of course, all heads are going to have different things on them, but this is a good representation of what you're going to be looking at, or what you'll see. And if you have any questions on this, there should be comments or a place where we can all comment on it. But anyway, that's your heads.